Yeah, that looks good. Alright, this video is about predicting the pH when they ask you a question about the pH being less than 7, greater than 7, or equal to 7. This is a classification problem. You've got to be able to recognize a salt, an acid, and a base. So if you think back to how we define salts, it's made up of a metal and a non-metal. So this will be the cation, and this will be the anion. Now you can also form a salt with polyatomics, so you have to just recognize your polyatomics. That's why you need to memorize them. Okay, acids. You should see an H with some anion part, and a base. Not all bases have hydroxide, but most of yours will have hydroxide. So something like sodium hydroxide, or we learned one special base that didn't have hydroxide, and that's ammonia. So you got to be able to recognize these things. So on the homework for your break, I gave you a bunch of identification things. Okay, so let's look at this. Would you classify this as an acid, or base, or a salt? Well, the first thing you should do is see if the cation is a metal. Sodium is a metal. This is a polyatomic. That is definitely our definition of a salt, a metal and a non-metal, or a metal and a polyatomic, or a polyatomic and a polyatomic. So this is a salt. Okay, so as soon as I have a salt, I have to think about sodium came from sodium hydroxide, and the anion is the conjugate base of an acid. So take your polyatomic anion. This is where you got to know them. This is a nitrite. It's not strong. Put a hydrogen on it to make the acid. So this gives you your nitrous acid is a weak acid. Therefore, its conjugate is strong. This is a strong base. Its conjugate is weak. Sodium ion in solution is going to be a spectator. So if I'm going to predict the pH, the one from the strong base not going to react with water. This came from a weak acid, therefore it's strong enough to react. So I'm going to have NO2 minus. Now I need to classify this. This is a conjugate base. Therefore, its pH has got to be greater than 7 when it's in solution. Number 2, barium iodide. Okay, this is This is metal. This is a non-metal. Definitely a salt. So now I just got to remember barium hydroxide. Barium is charged 2+. I need 2 hydroxides to balance the charge. That is classified as a strong base. Okay? So therefore this is too weak to hydrolyze. Okay? Iodide. I minus. That's the conjugate base. What's the acid it comes from? HI. This is definitely strong. That's in my strong acids to memorize list. So neither of those will react with water. When you have a salt that was made from a strong base and a strong acid, we said in the last video, pH is 7. You have a neutral solution. Alright, here we go. So now we have a polyatomic and a polyatomic. Those are still salts. So I have to think about hydrolysis. So ammonium is the conjugate acid of what base? Ammonia. This is weak, therefore that is strong. That will react. Nitrate is the conjugate base of what acid? Nitric acid. Oh, that's strong, therefore this is weak. Not going to react. So the only one I have to worry about is the hydrolysis of this acid. It's a conjugate acid. Therefore, since it's acidic, pH is less than 7. Moving on to this, is this a salt? Well, that hydrogen is not a metal, so this is, we should recognize it with an H. Acids are going to have H with an anion, so this is an acid. Strong or weak? Well, it's not in my strong list, therefore it is weak. Weak acid, but who cares? It's still an acid. pH is less than 7. Don't have to do any work. This looks familiar to me. It should remind you of ammonia, NH3, nitrogen with 3 hydrogens, except 2 of the hydrogens have been replaced by this methyl group. Who cares? It's still a weak base. So look for those ammonia-like bases. So this is a weak base. Definitely doesn't have any metals. Don't let this H fool you and try to make you think it's an acid. You've got to recognize ammonia-like bases. So this is a weak base, pH greater than 7 for any base, strong or weak. This one, okay, looks, I derived it off of this. So you have your 2 methyl groups, nitrogen, 2 hydrogens, and then this perchlorate ion. So this, you got to think of this way. This is the anion, and this is the cation, and that should remind you of NH4+. Nitrogen with 4 things attached to it, 2 hydrogens and then 2 methyls. 2 plus 2 is 4. So this is like ammonium, and you know ammonium is a conjugate acid. So this is actually the conjugate acid of that weak base. Therefore, since it came from a weak base, it will hydrolyze. Chlorate ion came from this acid, which, that's in our strong list. Light bulbs going off, right? It's strong acid. Therefore, its conjugate is weak, too weak to hydrolyze. So this time we have acid hydrolysis. So the pH is less than 7. And that's how you've got to classify each thing. Do not think you're just going to know the answer when you look at it. You've got to decide, is it a salt, is it an acid, is it a base?